So again, on page 162, starting section 4.1, Introduction to Matrices. Have you guys done matrices before? If you recall. Matrices. You do that in geometry or algebra 1. Some of you are nodding yes, some probably don't know for sure. Today, this is just an introduction, so this will be a pretty easy section. Most of you will be done, especially if you don't have any more tests to take at the end. Really get this done pretty easily. There's some vocab, just things you need to know. It's basically, it is what it says, an introduction. So we're kind of going to skip over to page 163, about halfway down there. It says in a matrix, numbers or data are organized so that each position in the matrix has a purpose. Each value in the matrix is called an element. A matrix is usually named using an uppercase letter. So they have matrix A there. And mine's not the same as that, but the same thing. So they are going to be called by, normally named by an uppercase letter. So in the next section, we'll be adding a couple of matrices together. So it will say like add matrix A and matrix B. Each number in here is called an element. So all the individual characters inside there are elements. And rows go horizontally. So this will be row 1 and row 2. How many rows do we have in this matrix? Just 2 rows. And you're going to, the dimensions, rows come first. So it's rows by columns. Okay, and the vertical ones are the columns. So this will be column 1, column 2, and so on. So how many columns do we have in this matrix that I'm drawing up here? 3. So in naming this, or dimensions would be a 2 by 3 matrix. So it's rows by columns. Rows are horizontal, columns are vertical. And some of your homework problems is really that simple. It just has a matrix there. You got to tell me the dimensions of it. So just getting you familiar with how they look and how to name the dimensions. Down at the bottom of page 163 has some bold words. I don't know if yours are highlighted or just mine, but anyway, there are words down there you need to know. Row matrix and column matrix. I'm going to write them up here. A row matrix just has one row of numbers. Just one row. Column just has one column going up and down. Not more than that. So that's a row matrix and a column matrix. If you see that in your instructions, or if I say that, you just need to know what I'm talking about. A square matrix just means it has the same number of rows and columns. So it's 2 by 2 or 3 by 3 or 4 by 4. It's just a square matrix. And a zero matrix, all the elements are 0. And we'll use that later on in the chapter, but right now that's all you need to know about it. All elements are 0, and it can be any dimension. 0 matrices can be any 6 by 6 or 2 by 5 or whatever. So then over at the top of page 164, we talk about equal matrices. You do need to know that as well. It says 2 matrices are considered equal if they have the same dimensions and if each element of one matrix is equal to the corresponding element of the other matrix. So basically, they have to be exactly the same. There can't be any difference in them in order for them to be equal. And they give you 3 examples there. On page 164, that top example, is there any difference between the one on the left and the one on the right? No, they are exactly the same. They have exactly the same dimensions, and each element is the same as the other one. So what's wrong with that one in the middle? What? Again, we're on page 164 at the top. Why is that second example not? Why are those not equal matrices? Right, the dimensions are not the same. So that first one is a 3 by 2. And the second one is a 2 by 3. So then that last one, why is it a non-example? The dimensions are the same there. Right. Some of the elements are not the same. The first one is they're both 1s, but then going across the top, 1 is 2, and 1 is an 8. So those are not equal. So going ahead there to that example right under there, example 3, we have y and 3x. So what's the dimensions of that one? How many rows do we got? What? These are like this 3x, that's just one element. So how many rows do we have? 2, and how many columns? So that is a 2 by 1 matrix. And it tells us that that one is equal to that matrix. And again, that one is, there's only one column there. That's 6 minus 2x. That doesn't count as 2 separate elements. Since they're connected with that minus sign, that's just one element. Even though I see there's obviously 2 different numbers there, it's just one element because it's got a minus sign between 6 minus 2x is one element. And the 31 plus 4y the same way under there. So again, as an introduction, all they're saying here is if these 2 matrices are equal, and it says that they are, then you can set each element equal. So you can set this one, the y, equal to the 6 minus 2x. And you can set the 3x equal to the 31 plus 4y. So if they tell you they're equal, you can set the corresponding elements equal to each other. So what do we have there? This is a system from last chapter. So we have to solve it as a system using either substitution or elimination, or you could graph them both in your calculator and get the answer as well. Doesn't really matter to me how you do it. What would be an easy way to solve this one? Substitution. Since it's already solved for y here, you can just plug that in right there. So what do we get for x? X equals 5. So now when we get our y then, what? Plug it back in, probably the one that's already solved for y. Would seem to be the best way to do that. So y equals 6 minus 2 times 5. So y then is -4. Some of you on your test didn't list that as an ordered pair. I don't think I counted off. I probably should have. But do that from now on. When you solve a system, the answer is an ordered pair. That's how your answer should look. Questions over any of that? The biggest things you need to know are how to figure out the dimensions, how to name the dimensions, and then how to set these 2 things equal like we just did there. So over on your homework, we're going to do 1 through 26. looking at number one there, we didn't do an example of this, but they just want you to put those temperatures in a matrix. So they give you kind of a table there. And a couple of your other homework problems are the same way. They just want you to list out those temperatures in a 2 by 5 matrix there.